Research into how a vehicle should protect its occupants during an accident is making steady progress. In the event of a substantial frontal impact, the occupants are protected in different ways according to a precise time sequence. First of all, the bodywork collapses, as it's designed to, while the passenger compartment maintains its rigidity. Next, the seatbelt inertia reels lock up and the pretensioners are triggered. And finally, the airbags are actuated. Over the past few years, research programs have also investigated the protection of occupants against side impacts. All the systems operate according to the same principle. First, special sensors measure the rate of deceleration. The computer then analyzes these data and initiates a decision, followed by actuation of the seatbelt pretensioners and the airbags if fitted. There are two kinds of deceleration sensor: electromechanical devices and accelerometers. The early types of impact sensor employed the inertia of a mass to make a contact. More recent electromechanical sensors utilize the inertia of a magnetic mass, which closes an inertia leaf switch, ILS. Clearly, therefore, these switches have only two positions, open or closed. To lengthen the period during which contact is made, certain sensors are fitted with a double spring system. Accelerometers can precisely measure the rate of deceleration. This enables the computer to vary its response according to the magnitude of the impact. A mass is attached to a piezoresistive support. In an impact, the piezoresistive part deforms and supplies a voltage proportional to the deceleration. Thus reducing any risk of the passenger sliding under the belt. When the system is triggered, a piston secured to a cable retracts the seatbelt buckle by about 5 centimeters. piston and cable system, similar to the buckle pretensioner, but without a non-return device, retracts the belt by about 10 centimeters. In another, more compact system, known as the rotary pretension system, balls are projected into a toothed wheel. In a heavy impact, when the passenger is thrown forward, the tension in the belt can reach 900 decanewtons, with a risk of injury to the chest. The reels are fitted with a torsion bar system to limit the tension. In this way, the tension can be limited to 450 decanewtons. The airbag system consists of two main parts: the gas generator module and the airbag itself. The gas generator module contains a detonator which is electrically connected to the computer. The detonator consists of a filament embedded in an explosive mixture. In a second stage, the detonator ignites the main nitrocellulose-based charge. This explosive is a propellant which doesn't require oxygen for its combustion. Certain airbags employ hybrid gas generators. A mixture of inert gases, mostly argon, is stored under high pressure in an annular reservoir. When the system is fired, the detonator triggers the main charge. This creates a pressure surge which breaks the bursting disc and allows the pressurized gases to expand. The gas produced inflates the airbag in a few hundredths of a second. The airbag is made of polyamide and incorporates a vent for rapid deflation. Certain types of airbag are of the programmed rip type. They remain inflated until there is contact with the chest or head. A weak seam then opens the vent and deflation takes place. The module housing is pre-cut to allow the airbag to deploy, while remaining attached to the vehicle. Statistics show that 25% of impacts come from the side, but these side impacts account for 40% of serious injuries. With a view to reducing such effects, we've seen the advent of seat spacers, door reinforcing bars, padding blocks, and side airbags. The side airbag, with a volume of about 10 liters, contributes to making the movement of the passenger away from the side of the vehicle more progressive. The so-called dual or head and chest side airbags also protect the head. The Peugeot 607 is fitted with side airbags of the high-level type, located in the head lining. These protect the heads of both the front and rear passengers in the vehicle. The triggering of pyrotechnic devices inside a passenger compartment is always a shocking event, both psychologically and physically. The triggering strategies must therefore be as precise as possible. Closure of the electromechanical safety sensors powers up the detonators. Once the accelerometer transmits a voltage signal representing undue deceleration to the computer, the latter earths the detonators and firing takes place. Because two different systems of sensors are used, the computer can disregard any spurious signals, whether these are mechanical or electromagnetic. The computer has a reserve power source so that firing can take place even if the main electrical supply has been lost. The pyrotechnic seatbelts are triggered only if the impact is frontal at a vehicle speed exceeding about 15 kilometers an hour. The frontal airbags fire for frontal impacts at a speed exceeding about 20 kilometers an hour. However, they do not fire for side or rear impacts, or when the vehicle is traveling over a bad road. The same applies to impacts on a 15-centimeter curb at speeds under 30 kilometers an hour. In the event of a side impact, only the side airbags on that side fire. Automobile Peugeot introduced its first airbags in the 605. These followed the American practice of having only a driver's airbag of large volume, 60 liters, seatbelts not being compulsory in the United States. The computer is located under the passenger seat and incorporates the mechanical safety detector. Two mechanical deceleration sensors are placed on either side of the vehicle at the top rear of the engine compartment. The warning light appears on the instrument panel. The pyrotechnic seatbelts are operated by two self-contained units located under the seats. In 1994, a new system, the AIRBAG, was chosen in preference to this. The entire system is incorporated in the steering wheel. It's easily identifiable by the warning light on one spoke of the steering wheel. The seat belts are operated by another unit fitted with a mechanical sensor with a single spring. This unit does not include an accelerometer. The same unit controls the pyrotechnic seat belts in vehicles that are not fitted with airbags. With the advent of passenger airbags, designs changed once again. The computer underneath the central console integrates the two sensors, a double spring electromechanical one and an accelerometer. The computer actuates the airbags as well as the pyrotechnic seat belts. When a child seat is in use, The passenger airbag can be temporarily switched off by means of a contactor. If the vehicle is fitted with side airbags, these are operated by independent units that include an accelerometer but not an electromechanical sensor. A special side airbag warning light appears on the instrument panel. The passenger, 90 litres. The ordinary side airbags have a volume of 10 litres, and the high-level side airbags a capacity of 35 litres. The 5 seatbelts are fitted with force limiters, set at 650 decanewtons at the rear and 450 decanewtons at the front. The computer also receives signals from 2 integral piezo-resistive sensors positioned at 45 degrees to the center line of the vehicle. The computer can determine the direction of the impact by differentiating the signals from these 2 sensors. If the impact is frontal, the deceleration is the same for both sensors. Comes from 45 degrees on the left-facing sensor detects a substantial deceleration, while that facing to the right detects little or no deceleration. Other piezo-resistive sensors, the so-called satellite sensors, secured to the longitudinal member at either side of the vehicle, detect any lateral acceleration or penetration. All these data are analyzed by the computer, which can then estimate the magnitude and direction of the impact and optimize the protection of the occupants. The contactor for temporarily switching off the passenger's airbag is on the side of the fascia at the passenger's side. If the passenger's airbag is in fact switched off, this is indicated by a warning light on the instrument panel. Another warning light remains on if the driver's seatbelt is not being worn. The computer continuously monitors the system and indicates any malfunction by an indicator light. The Diag 2000 can also be used to test the system and to indicate any faults stored in the memory. It should be noted that if the system is actuated in an accident, the computer goes into a locked mode, meaning that faults cannot be erased. It must be replaced. Most computers are programmed to operate a precise number of detonators. Thus, a four-way computer corresponds to a system with two pyrotechnic seat belts, a driver's airbag, and a passenger's airbag. Note that some passenger airbags have two detonators, in which case the computer will function over 5 channels. With a view to simplification, certain computers are supplied unconfigured. The Diag 2000 can be used to tell the computer the number of channels it should operate. Warning: this remote setting is irreversible. It is essential to read the servicing procedures before working on the system. Disconnect the battery and ensure that the supply lead is physically separated from the battery. Before working on the system, allow the period of time stipulated in the procedures to elapse. The connectors in the firing circuits are fitted with a short circuit bridge to prevent any accidental triggering by static electricity. The airbag should be stored with the bag uppermost. No repairs are allowed on the detonating leads, which must systematically be replaced. Never use an ohmmeter to make measurements on the pyrotechnic systems. Special plugs are available to take the place of the pyrotechnic elements while continuity tests are made on the leads. After working on the system, keep out of the area into which the airbags deploy when switching on the ignition. It should be noted that special seat covers have been developed for vehicles fitted with side airbags, and these must be used. On all the systems except the AIRBAG, the firing signal at the steering wheel is transmitted by a rotary contactor. This rotary contactor is in fact a ribbon cable wound round a sufficient number of turns to allow the steering wheel to be turned from lock to lock. Refitting requires precise positioning. On the contactor, align the 3 marks: reverse triangles, open box, and outer mark. The contactor is then in the mid position. Ensure that the vehicle wheels are in a straight ahead position and refit the steering wheel. Replacement contactors are supplied set to the mid position. Refit the contactor and extract the plastic tag. With the AIRBAG system, the rotary contactor supplies power to the system that is integral with the steering wheel. This is a track contactor, which therefore requires no adjustment. The pyrotechnic elements are guaranteed for 10 years and must be replaced thereafter. A detonating lead and a special support are used to detonate the pyrotechnic elements to be thrown away. These systems must be used. When a vehicle is to be scrapped, the pyrotechnic elements should be detonated. Position the vehicle in open space. Lower the windows before disconnecting the battery. Connect the detonating lead. Close the doors. Trigger the pyrotechnic elements. Airbag systems and pyrotechnic seatbelts are in continuous development. As a result, for example, of more precise sensors, electronics that permit more elaborate trigger strategies, and the use of seatbelts with force limiters, passengers are increasingly well protected whatever the direction of the impact, while reducing any risk of subsequent injury.